Okay, ich glaube, dann können wir mal anfangen. Alle Nachtische verdaut.
Let us begin. I guess all the desserts have been ingested. Alright, for the next 10 minutes I would like to talk about what happened in the microcore in the last 1.5 years. Sorry for the raw edition people, but we have a few minor things covering this, but not much. These are the major works. There was no red one with a super mega feature, but at least we have 4 medium to important works and then a few minor ones as well. So the first feature at the previous conference wasn't quite finished when we had that, but now it is fully operational, which is real-time checks. So what is the issue with real-time checks? I mean, 1 minute check interval is, as a rule of thumb, is fine for most things, but of course not in every case. Let's say memory usage or other memory issues. In 1 minute, many things can happen. Or sensors that maybe you want to scan, like temperatures. Sometimes a minute is too rough. No problem. So let's just change the check interval to 10 seconds. Is a more or less good idea because you do create a lot of overhead with that. Where does it come from? Well, of course, with the agent, you talk about TCP. If you want to be very secure, then it would be secure share. And of course, then session keys have to be sent around with 4096-bit keys and all. So this is a performance matter. You just can't afford to do that on a regular basis. So it would lead to a high load on the client and the server. And even if you don't do it, the agent just does run more often and does collect a lot of results and performance results that you don't really care about, at least not in this small resolution. And then if you have a wide distribution on your 20,000 hosts, of course this also doesn't help much because then the core on the monitoring server is also working under a much higher load because it has to process all the check results and the performance data has to be saved somewhere. So this only works to a certain extent. So I better not move. Apparently there's a loose contact somewhere. Okay, now it is here. Our solution was that we take a 1 second resolution and have a push model via UDP. What does it mean? So let's look at the normal check cycle. On the left side there is the server, and right we have an example client with CheckMK agent. Once a minute, the core decides, we need to check the client according to the configuration. It contacts the client and says, please send me what you got. And the client sends it back. And then the results are being processed. All good. So if you have configured for this client that you want a real-time check result, then the client will, the agent will fork on the client, making a copy. The normal check cycle continues, and for a certain amount of time, the copy of the agent is working, which is then once per second via UDP sending back check results over a configurable amount of checks. What this leads to is a much lower protocol load, which cannot be underestimated, and also the real-time agent keeps working. So it's not. I mean, if you would have to start it once a second, it wouldn't be fun on the client, because you don't want to like smother the client with work. So of course there's a catch to that if you look at it for a second, because anybody could come up and just ask for check results, push check results to the server via UDP, which is not fun. So it's a network configuration issue whether this is a problem. I mean, you could have firewalls or DMZs, so you cannot even allow a push. I mean, if you do that, it's fine. But usually this requires a bit of thought, and the solution is just like a normal agent output, which can be encrypted. I'm not sure since when, it's 128 probably. But you can also encrypt UDP packages. So not everybody can just push something onto our server. Little disadvantages, you don't have to do this. Via OpenSSL, you do have an encryption and decryption, which could be a problem on very weak clients, but usually it's not an issue. So configuration, as usual with CheckMK, it's rule-based. The entire configuration can be packed into one and rolled and deployed to the clients. It could be done manually, but who would want to do that? The question is which checks or which results are being sent. Currently, we have a selection of checks that all come from the CPU area, like load, memory, workload, things like that, so cheap checks. We can extend this quite easily on request, but maybe on a Windows client it wouldn't be nice to have a software inventory through the registry once a minute, because, I mean, that alone takes a few minutes. And what we can configure is how long should this cloned agent live for. It would be nice if you turn off that it would just disappear on all the client, and if you, like for company reasons, if you need to deactivate it at some point, of course you could set that up. A few things need to be thought about here. The standard configuration for the RRDs are a bit too coarse. So if once a second you get a value and then you have them combined to a 1 minute, so you need to reconfigure your RRDs. Not for all hosts, of course, if you have 20,000, for example, because that requires a lot of memory. The measuring results have to go somewhere. If you like programming a lot and have strange requests, of course you could script it. The protocol is quite similar to the one the agent has anyway, and on request we could definitely give you tips on that. If you want to push things, for example, that do not come from the CheckMK agent or maybe from your own program that you have hacked up and you think you want to have that in the monitoring, this is quite simple to do. Another tip, it is quite easy to kill your monitoring like this if you have alerts, for example, that give you an alert on every check result from every host or servers, and or if you have Graphite connections connected, Graphite connected setup that send all the performance data to another system. Question so far? One question. How is it triggered? I didn't get it. If it's a normal agent schedule, I mean, there must be some parameter that sets it up so the host knows I now have to deliver real-time data. This is the normal check cycle here. And if the agent, through its configuration on the client side, knows there are real-time issues here, then if there is no fork yet, it creates one, and it will be there for the time till timeout. So, for example, if you change the configuration and then you don't want real-time checks anymore, of course this has to go away at some point. But as long as it's configured to work and send data, it will do that automatically. Right now, this is not configurable with the right amount of money. It could also be configurable like 2 seconds, 5 seconds, but right now it's hardwired to 1 second. I think there was another question. So will the server always accept UDP messages with that content? Or is it just for one host? No, the server does accept everything. That's why I said it's nice to have, if you have an open port, some kind of encryption. And if the encryption is wrong, then it will not be processed as a check. But by nature, it takes everything. Is it documented? Yes, I guess it's documented. I asked our documentation master, Matthias. He says yes. All right. So what is not documented? I think the formatting, if you want to write it yourself, but on request we can certainly do that. It's not that hard. I think that's everything about this topic. Graphite is something I mentioned before. I think it was at the previous conference at 128, but we have expanded on it. So first of all, what is a graphite interface? Or what is the protocol behind it? It's quite a primitive text-based protocol, which can be used to send metrics around. It's like triples of what value is it, what's the value, and what was the time it was taken. The basic thing is that it can talk to a lot of software. I have the most important ones here: Graphite, of course, then InfluxDB, and which is also quite hip these days is Grafana. And some already use it as their own dashboard for other things within companies. So of course people did ask us to get our performance data in there. I mean, we do have our own graphing, but for any reason it may be useful to put it into other media as well. Like dashboards and trend analysis could be combined. It's a different world, but we do offer that and cater for that. So what were the improvements or enhancements? I mean, looking at real-time checks now, it's quite useful to have the sending metrics for services and make sure that it can be disabled. Thousands of hosts can send their data. It would be nice to be able to turn it off. And another thing was that we wanted to have the one crit min-max levels in the graphs and be able to see them. Originally, this wasn't possible because they can be variable depending on the service. And the lower one looks a bit strange, but the performance values are just strings. So how do we map them, the host service and the performance values based on strings? The original mapping wasn't invertible. For example, we do replace a lot of special characters with underscores. And if you monitor files that have underscores in them, it's quite hard to split a string. What was a pass? What was a service? So now, optionally, it's a very ugly but mechanically easy to achieve to have a mapping. So you have a mapping of these weird performance names to human language anyway. So logging problems, if everything's fine, everything's good, but if things go wrong, you need this. If I have a logging level that's too low, there will be information missing. On a higher logging level, I typically have in 128 there was a problem with debugging large installations. We had dozens of megabytes per second, and that's not fun to analyze. And it was still inconsistent in different parts of microcore. We have worked on that. Now there are 9 separate areas for this that can be separately set up, like alerts, downtimes, RRD processing, and many other, if you have a bug anywhere. And for every area, you can set up diverse logging levels. It doesn't work on the helper side, but I think this will happen soon. And this is really quick. The only thing that people want to know about the raw edition, a few things that alleged status were changed, but it's more esoteric. The first thing was queries can be worked on up to 500 megabytes. I mean, there are servers that send you a 500 megabyte XML reply. It used to be just deleted and thrown away, but now we can do that. We can work with that. Now for binary fields, we also support different output formats like CSV, which actually works. Also Python 2 and Python 3. That wasn't possible before. Then with the filter operators, we generalized a few things. You can look that up on the website. So every operator with every field can be worked with useful semantics. And you can do a bit more complex queries, like give me all hosts that do not include this and that service. This is for people who want to make up their own queries or script things. Then there's a few minor things. Let's skip that. So let's check timeouts per service. The final thing is our smart ping. In our training, I always keep talking about this. Sometimes switches answer for hosts that are down and say TCP reset won't work, but our smart ping then sees, oh, this is an answer. Our host is up. So this is something that can be turned off. And it depends on the network infrastructure of the switches, whether you need to have this on or off, and a few really minor things down there. That's it. Bit over time, but all right.
Lots of interesting things in here. Okay, one thing that might just be interesting in terms of information is I have a graph here that I prepared for you, starting with the version 1.1.0, end of 2010. It was about 30 check plugins, and version 1.2.6 was about 700, and today we're at 1,300. With 1.2.6, the hardware software plugins were, and the mentoring software. And in the beginning was about 30, and now we're at 70 as well. And in both cases, the trend is still going up. So that means we have a lot of requests for different plugins in general, whether they're check plugins, hardware, software plugins, all of them. Okay, then I would like to talk about the development process. So like I said, this is just an average. We have about 15 requests per week, up to 15 per request per week. Sometimes it's more, sometimes it's less. We're booked until the end of June already. So in our check team itself, we're 3 people. And because of that, we have about 2 months of time that you need to book in advance. Since last time we implemented 320 different features, so that means almost 1 feature a day. And what does this process look like? Well, the development process, of course, first starts with the customer's request, and that is then sent to the check team made up of 3 people. That's Marcel Ahrens, Konstantin Büttner, and myself. And then, of course, we distribute them once or twice a week to all the different developers, so 1 out of the 3 people. And the developer then has different tasks. Of course, first of all, he needs to understand what the application or the request is really all about. So what does it do? What needs to be done? What needs to be monitored? And then, of course, they're also in charge of implementation and also testing. And of course, if an MKP is requested by a customer, usually that is the case, then of course they're doing that as well. And then if there are questions or maybe if there are some details that are unclear, of course, we always have conversations with the customer. So once this step is finished, the next step then is the review system. So that means that's part, it's just going through the review system, and Lars is going to tell you a little bit more about that later on. And of course, that's something that needs to be finished as well. Once that's the case, then it's going to be released. So that means that the feature is then part of the master branch. Okay, so once in a while we get some requests. For example, I want to monitor device XY, and internally we have a questionnaire because, of course, we need lots of different data. We need more than just a statement. So first of all, we need to know what needs to be monitored and how do we get the data. So is it agent or SNMP? And of course, you should be familiar with that. And then, of course, the test data is then absolutely necessary. That's really the basis because we don't even know what we have to do if we don't have that. Especially in the SNMP case, MIPS are very, very helpful to really translate the WATO and then also to find out what the data source is. So where is what? Okay, then we have questions in terms of the configuration. Okay, what does it need to be able to be configured? Yes and no, and then values, things like that. And of course, questions like different metrics. Are there metrics? And I check, and what are they like? So is it a set range, or can they be combined? And then cluster aware or not. So that means if there are sets of data from different nodes, can they handle that? And then also the last 2 points I already mentioned already. So for the development for the master branch, and then also if a backport is needed or not. Usually that can be done within the MKP. If not, then we can also put in a patch. Okay, so when it comes to development, sometimes there's some difficulties, of course. So, for example, it could be that we have commands OIDs that have changed. And of course, we want to stay compatible to older versions as well. That's very important. Or maybe there's no documentation or outdated documentation. And of course, we're working on our handbook very, very tirelessly. And of course, the next problem could also be that sometimes licenses are required from third parties for libraries, things like that. And then sometimes also we have very complex outputs or structures, specifically Cisco QoS tables, things like that. So of course you just have to put some time into understanding what that is. So then the last point, I would like to give you an example. So I tried to make it that you can really understand it. So we have an SMP component. So that's Werk 4158. So you can read that there. So the task was to really have all physical components from all SNMP devices. So that means really putting them into the hardware software and implementing it there. And those physical components could be fans, sensors, modules, and also others, of course. And the ports are left out because they can be found elsewhere already. So the data always stem from the entity MIP. And of course, nearly everywhere it is SNMP device supported. So it means it doesn't depend on the manufacturer. Then all these physical components are then organized in a tree structure, and I would like to show you 3 different examples for that. Okay, so this could be a tree of a Brocade SAN switch, and like I said, we left out the ports also for all the other ones. And overall, it's organized in a chassis, and it has different contains. And then in the end, we have power supplies or fans as well. And Another example could be Cisco Nexus. So it looks a little bit more complicated, as you can see. So again, it's organized in containers plus modules. And in the end, we have some sensors, but it could be all different sensors, of course. So temperature, humidity, things like that. And a lot more complex is this example. And again, this is not the end of the story. I just didn't include a more complicated example because otherwise you wouldn't be able to read anything anymore. So the task really was to really have trees and really write a plugin for them so that the data is then part of the hardware-software inventory system with index, name, description, series number, and so on. Okay, so that was everything I wanted to tell you, and I'm going to hand over to Marcel right away, and thank you very much for listening. I'm going to show you a couple of different works, prominent works, and I'm going to introduce one that most of you probably know because it's been there since 1.8. So Konstantin has reorganized the temperature checks so that now we... why doesn't this work? Okay, so the temperature values can be configured one way versus, I'm just not going to move anymore. Compared to what it was before, so you just have different rules beforehand. So the advantage is that we can have different services and we can configure one rule and you don't have to configure 20 as was the case earlier or in the past. So this principle was then used, of course, for other rules, for example, to control fans or maybe humidity, for example, for Kentix devices and also others. So, of course, all that works with one rule set, and yeah, it's just easier that way. Okay, so again, you can see the rule itself. So you can just see what's happening here. So we have all different scenarios covered here. So we have upper temperature level, lower temperature levels, things that can't be too warm, and then also others, of course. So for example, also the trend computation. And then 3 other works, for example, is a very new one. So in the past, what happened was if you have Windows and Linux, if you want to monitor logs, you would have to configure them differently. So you would have to really read up about both ways, and you had to deal with that. And with Windows, it was not case sensitive. On Linux, it was. Now it's a lot simpler, so that if you're using Windows, the configuration is equivalent to Linux. And I think that's a very, very good feature, and I think very interesting to many of you. And the second one is a feature that many of you probably also know from the Linux agent or the Linux plugin from Oracle. So we are now supporting the wallet. So that's equivalent to the plugin on Linux. And also the third works is then the MTR plugin. And that is a combination of Ping and Tracewood plugin. And in that case, there are 2 different points the hops are being measured. It's measured what the latency between the hubs is, and then also the deviation and so on. And yeah, I have a good example for that here as well. So we have 3 nodes right here. It wasn't very easy to really find a server where I need 15 hubs, so I had to look quite a long time. I found Vietnam here, the stock market. So why did I do that? Well, I wanted to show that you have to be careful for the RRDs. They're a big difference in terms of size of the RRD data. And if you look at matthiaskettner.de, I only need 8, and that's about 18 megabytes RRD. And if we go to Vietnam to the stock market. That's 15, and we need about 38 megabytes. So you have to be very cautious, especially if you have several ones that you really don't fill up the system too much. I have another prominent work, and that's the HB3 bar. That's probably very interesting to many of you. That's only been implemented since February, but many customers are very happy about it. And this is a third way of what Simon already introduced earlier. So we have agents, we have SNMP requests, and then also the special agents. And what you see here, the 3-par is also using HTTPS. And that means you don't need any extra ports. You don't need to configure anything. You just set up the agent, username, password, and also the things that you want to get. And of course, you can configure that as well. If you say, for example, okay, I only want the virtual volumes, for example, I don't want the ports, then you can just indicate that. And by doing that, if you have bigger environments, for example, you can reduce the data load and you can maybe leave out unnecessary data. And for that, we already have some extensions that were programmed that really shows how interesting it really is. And of course, you can also just use rules and configure them. So don't be surprised now. It's a little small. This is just supposed to show you what we can monitor with that. And what you see here, we have the hosts that can be monitored. We can access them, and then also the storage overall. We have type of disks, of course, so if it's SSD, SAS plates, or nearline SAS, and so on. And we have ports that are monitored, and of course the virtual volumes. That's what's actually interesting here. And of course the first extension then is the replication between those 3 nodes. And I'm not sure, you can probably not read it in the back, but what you see up here, that's the base check. So in this case, we have 4 nodes online. And if one doesn't work, then of course there's an alarm. If there's 2, then of course that wouldn't be good. And again, we are monitoring the replication between the individual nodes, whether it works or not. And then the second topic that I would like to introduce is the hardware-software inventory. Again, many of you already are familiar with that. What's very important is still that even in this version, that the hardware and software inventory is not activated by default. You really have to set the rule for that. And once you do that, then you get some data, not a lot, but some, but things that you get from the agent already, for example, memory things or the interfaces. And with the plugin, you get then a lot more, of course. So yesterday I just checked again, so it was about 22,000 data that I received. So if you then configure that, and that is true for 3319, then if the check it doesn't work because the host is down, for example, for whatever reason, or it's not reachable, then you can configure it also in a way that the check is still okay. And that wasn't possible so far. And then a second thing when it comes to hardware software inventory, and is a big change, is the new API over HTTP. So before, it was under special circumstances, it was very complicated to really find that out with the download button XML. But the disadvantage was that only if the things were open in the view, then you receive the data in the XML. If everything was not open, then of course you didn't get it. And of course that's not good. And because of that, there's the API now. So the API gets all the data from one specific or also several hosts, and then passes on the data to in some different formats. So we have XML, JSON, and Python. So I think most other programs that receive this data can handle at least one of them so that they can then process them further. And that's very easy. So I have a second example for you. Please do not be surprised. This is just so you can have a visual picture. So on the left-hand side, we have an excerpt of my own laptop, and then also the packages that are installed right here. That's what it looks like approximately if it's coded in JSON. On the right-hand side, we have almost the same thing again, an excerpt of XML. So as you can see, it's very, very easy. Okay, so that's it. I'm gonna hand over to my colleague, Konstantin, who's going to give you more information.
Genau. Neues im Core System.
News in the core system. So the backend that is not the microcore. What has happened? Nothing really well changing, but a few things have happened, and I just picked a few. What many will be happy to hear, errors in the checkmk configuration does not prevent that the core is being restarted. So it used to be a problem. My configuration has an error in it. Maybe I made a manual change in a text file somewhere. I want to restart it, and it wouldn't let me restart until I found the error, and that is an annoying situation. So new now is that per site there is a warning that there is an error in the configuration. Please take a look. But there's always a correct core configuration being written out. Some will see it doesn't sound so new to me, which is true for the CMC. This was already available in July 2015 before the conference, but now it's also in the core. So everybody using the raw edition will be happy to hear. So who works on Nagios or Integra, although you're using the Enterprise? Okay, there's just a few. They're dying out. All right. So recurrent downtimes is now also available for the nth day of the month and the xth day of the weekday. Well, what does that stand for? Sometimes I want to have something like on the 23rd of the month I want to have a downtime, or the second to last Tuesday of the month should be my downtime, or maybe the first Monday or whatever. So there will be examples, and you can see that I can also count backwards for the weekdays. So for example, the final Friday I want to have a downtime at 6 p.m. and this is something that's easy to display now. Apart from that, tool monitoring, classic problem. We have a server with management board. I can access my client through the TCP or my agent, but the hardware information comes through the management board. I do want to use that too. So it used to be I need two hosts. One has one IP address, the other one has the other. And this somehow works, but it's inconvenient. Therefore, we have a solution now. There is an entry management board here for the host properties. We have protocol and IP addresses. I can choose them. I have left out that protocol only supports SNMP right now, but there may be another option. I mean, so far this is the most common option. Final step in this field is the agent encryption. When did that happen? Actually, not long ago. One reason is the real-time checks that we heard before. I mean, before that, I could somehow have an encrypted access to my agent if I did everything manually. But then I have to do everything by hand, and it's not integrated into the bakery either. But now, simple solution, there's one rule encryption. I can create a passphrase, which of course is rule-based depending on the host, and these two lower options here say I can configure what's going to happen if I get an encrypted or non-encrypted response from a certain host. So let's say the host is supposed to send encrypted data. What happens if unencrypted data allegedly coming from that host comes in? Enforced means data is being dropped and it came in clear, unencrypted. Or I can configure that both types of data are being accepted. The real-time checks are being configured with the same rule, and this one rule also controls the bakery. So this is one point where I really can have one rule controlling it for all the hosts. I don't have to make like comparison what is being accepted because the bakery in this case does a central job of performing this. So let's say I have a host that encrypts its data nicely, and then something unencrypted comes in. The check-in-case service goes to critical. For those who can't see it, agent output is plain text, but encryption is in false. And the checks behave like there's new data coming in because the wrong data came in, it was discarded, so they are set to stale, which corresponds to the feature we saw before. Actually, I'm pretty much running out of time. Any questions to this before I give the mic to Sven? Yeah, we do have time for that one question. Can I have a text-based encryption? Yes, it's a rule chain. I have all the features that are common in rule chains. Host text, folder, everything. Any other question? Yes. I have a idea for check development. If something large comes up, could you probably think about having crowdfunding, maybe? I think every year somebody makes this or gives us this idea. Well, crowdfunding, maybe a bit off topic. The checks are usually small and large things. It's hard to find customers because they do expect different features like IPv6 monitoring. I mean, we didn't have a public crowdfunding for this, but we know who was interested in what. And then this concept did get funded with 2 or 3 big customers in the background. They financed it. Well, it doesn't have to be crowdfunding platform, but yeah, the idea that not one person pays for it because then it's not interesting, but like maybe pooling a few supporters for a check like this. I'm thinking about storage systems that, well, I mean, for now there's no special agent for that. Yeah, for things that do take a longer amount of time, we would probably internally have to think of something. I will let the thought foster in my head. Okay, so I'm handing over to Sven. Thank you very much. Technical challenge we can get going. My talk will be 10-15 minutes talking about the web API because there will be large improvements and changes because we want to add functionality and comfort when using our software. So what are the situations where it makes sense to use the web API and what can it be used for? In the file there are a few little examples. Most customers have some kind of asset management software. They have implemented this where you have basic data about the computers, the network devices, and so on. The OS, patch levels, support contracts, or maintenance contracts, when do they run out, and all that. And part of this data makes sense to be included directly into the monitoring. Otherwise, you would always have to look at both data sources manually, and then of course they will never be synchronous, so it makes sense for these kind of integrations from CMDBs or something to have an automated interface. The other factor is that many customers have custom solutions for managing their house or their devices, and they wanted to have some kind of option for an automation of hosts and services. So you don't have to manually do it through this multi-site or through WATO. Of course, this is much easier and quicker to do. The final point, of course, what many customers try is this complete lifecycle management. Like devices are being ordered, delivered, entered into the inventory, and then they're being used or being delivered to other sites. Then they are in operation for 3 to 5 years, and at some point they're being discarded. And for the entire lifecycle management, it is quite useful to try and automate it completely. It makes the admin's life much easier because there's one data source that needs to be maintained and everything's in there, and especially for monitoring what you need here, like a special configuration, special rule adaptations, all that would manually have to be adapted, but the rest is present. In general, the Web API is our standard interface to the outside world, which offers many possibilities to work on an automated basis with CheckMK. So I can get to work as I like without using the multi-site a lot. So what was the situation in our present stable version? Right now, over the Web API, you could add, edit, or delete hosts, like do configuration management. I could query attributes in CheckMK of the hosts or several hosts. So basically to get the information that is present for this host right now. Then of course it was possible to do a service discovery of a host. So if I enter a host, of course I also want to get it into the monitoring with the services perhaps that are by default there. So service discovery was necessary. A newer feature came with the agents, with the agent bakery. Of course, there it also makes sense to say I want to work with it on an automated basis, so I need the option to bake the agents accordingly. And of course, to have all the changes in the GUI automated and to make sure that all becomes active, all these changes needed to be activated. So that was the present point where we were. It's quite rudimentary. It's not full automation yet, and this is something that you need for complete lifecycle management, and we really didn't have that. Especially in large environments, you do want to go a step further, of course. And then in the past, we had a few larger changes where quite a few features were added. One change applies to local user management. You used to only be able to add users through the GUI. Now with Works 4023, you can automatically add local users, and they can also be edited as I need them. And as soon as the user is not necessary anymore, I can automatically also have it deleted. So this is only for local users. This does not apply to the Active Directory synchronization because there we couldn't just do that and have an automatic new user. Then there's another big one, the 4018, that says that we have made it possible to have the management of groups that you can use for visibility or for views can be created automatically now. I mean, these are just the host and service groups, nothing special running in the background, and the contact groups that you require to limit the visibility of services and objects. this is all in here, and I do have the option to create new host groups, service groups. I can edit existing groups, or I can also delete them. So I can go into deeper modification manually, of course. Then there is Werk 3805. I was able to create hosts, but the problem was there's also a cluster host that can be configured. And with this Werk, this functionality is now in the system. So this means that I can take separate nerves for cluster configuration and create them directly in the works. And I can then use this nodes to create a cluster, which is a nice function. Then we have created first steps. What is being about what is being sent to the web API. So these entries can be validated and checked whether they are actually whether they could be valid. It's about the major format. It just checks for major parameters whether they are present. It's not about validating content or commands or anything. It's not a complete pre-validation. Does this make sense, or is this a contract group that already exists? I mean, this is a second step. What we have now is something very basic, but in the future we do want to build up on that, just to be very safe with it. And in this work there was also a second reaction, which was only about 3 alerts, because we also want all the language issues that come from the configuration in the web API be taken care of. I mean, the most of the alerts came out in English, is in form of a hard language, and now they are soft and they can be translated into other languages. It's a minor thing on the side that we did. So you can see in this work that we have created a few basic stepstones in terms of automation. Of course, it's just a small part, because time-wise we can't implement, or we couldn't implement everything we wanted to. There are a few things, a few features that are to come. So in the future it will be possible to directly create WATO rules through the web API. But with the rule creation, it will be the case that these rules that could, for example, go to rules MK, I mean, the content would have to be automatically given to the web API, and we enter them into the correct place. I mean, the rule need to be adapted by hand, because the rules are so complex. You cannot create a general format that works. I'll just throw in a few attributes, and then in the background we create automated rules. This is not something we can do. Then, of course, the next point would be the configuration for rules, like automated host tag creation. Of course, it would make sense to create an automation for this, because usually in asset management systems, you do set up a few things, and then why not put them into CheckMK directly. Then, of course, it's also possible to create folders or delete them or edit them with the attributes, so that you could create complex directory structures. And for those customers who want to start a distributed setup, you could have slave signs with the matching configuration and with a one-time login coming from the site, just to perform everything there. So for all this configuration, you do not need the multi-site tool anymore. And for those customers who have the new Managed Service Edition, or want it, or want to use it for their customers, we will also have a web API that can automatically create customers. So this doesn't have to be a second step. And now I can give you a little demonstration. I have created a tiny demo here, showing you that it actually works already and how they work. And apart from this presentation, I will also distribute the demo script so you can see how to work with the web access and how to use it for your purposes. So I'm logging into my demo page. It's an empty page. I have created a few rules in the background so you can see that what I'm automatically putting in here actually makes a difference. So first I go into my demo site. I am in the WATO area host, where of course there are no hosts, but 3 example directories. The call for creating an order does not exist yet, so I had to do this up front. So I now press enter because now I'm gonna create the first host automatically. It's an example host, and then when I come back to my surface, to my GUI, and I refresh, then I suddenly see that suddenly there's a host here. I can also look at it and I find it all configured, ready to use. I can take a step further. I could just add a second host, and I just add a service discovery to the first host. So the automatic recognition of services, what's available here. And if I create a host, I always get a recite and a recite code with which I can check whether everything went well. And what I also get is text output, including how many services did I find, how many did I keep. Maybe I do have a host that existed before. And this feedback, this was one work, they can be translated now, so there's no language barrier here either. So going back into my page here and I refresh, I see that I have a second host now in my view, and I have a service discovery and created that. I'm going back, let it run again. For the second host, I do the service discovery and I activate all my changes so that it becomes active. I can go back to my page. I refresh and have my 2 hosts, and in my technical overview I can see 2 hosts with the number of services. So I let it run again because there are 2 more examples for 2 new hosts in the Linux folder with service discovery and the automatic activation. And going back and reload, I can see I have 4 hosts in here already. And go into my line folder. I have things in Linux now. Just a short cluster example. I add 2 nodes. I open the cluster, put the service discovery on my node. I activate all the changes. I can go back to my host list and look at it. And now I have this cluster with the agent type ping, meaning right now no services or something are being checked. It's just a ping. Because I simply wanted to do the demonstration, I'm editing my cluster host once again. And now I have the option, go into WATO, to my cluster, and look at the settings. I have the attribute agent type and reset it. And I set the criticality to business critical. So just you can see how these changes can be applied. And the next thing is an example for host groups. Now I can look at my page. It's supposed to be all empty. And I can apply these changes. These host groups have already existed before. For this demonstration, I let it fail once, so you can see what happens when you try to add something that already exists. So I do get a recite code is 1, so then I can look at it and see, okay, there must be an error here. And I can also request things accordingly. I just let the script run till it's done. And what I did in the background now was that I listed a few host and service groups. Now I can go to the views tabs for the host groups. For my Windows and Linux homes, I created 2 groups, so I can see, okay, these groups that I have created, they're being used for grouping properly. Same goes for services in the background. Here we have the service groups. Here's the CPU and file system, just as an example for all the machines that I just configured. And what I did skip now was the final step with the users. Here in the background, I have created 3 test users. As local users, you can set a password for them so they can be used immediately with all the attributes that are available. This just as a little demonstration. So that's the live thing. Any questions to this, to the web API? The thing with the groups looks interesting. You said rule editing is something that's gonna happen. How do you do the linking between hosts and groups if you cannot do linking through web API? Yeah, this is something I have entered into my system beforehand. So to make it work, because rule activation is not something that's in there, as soon as rule creation can be automated, you can then create groups first or the host tags, and maybe create a rule set for this accordingly. So I want to have my host tag Linux that goes into this group. So it's something you would usually do as well, like create a host tag or a rule and say every host with Linux in the name should go to Linux. And I mean, I would insert that, and if I have hosts that fulfill this requirement, they will automatically be used for this grouping. And this is something that I can automate. Can I do the rules the other way around? Like deleting hosts through this thing here? Yes, that works. Everything that can be added or edited can also be deleted. Die neue WATO API Dokumentation ist ja schon ist die schon verfügbar? Nein. Wir haben nur ein Handbuch über die alten API-Anwendungen, weil die neuen Funktionen noch unter Entwicklung sind und es wird ein bisschen dauern, bis wir das updaten können. Wann ungefähr wird es soweit sein? Ich kann leider keinen Zeitplan geben. Lars, maybe? Lars vielleicht.
Okay. Okay.
Also die neue Dokumentation wird aktualisiert, genauso wie also bis wir auch die
Hi. Just to double check, so the authentication mechanism that
Authentifizierungsmechanismus, der für Geräte funktioniert, gibt es den auch hier? Was für ein Timeout könnte ich da einstellen? Könnte ich dann einen API-User machen, der vielleicht eingeloggt ist, immer nur um meine Verknüpfung zur Datenbank herzustellen oder sowas? Nein, das ist nicht nötig, denn mit einer Automatisierung, also einem automatisierten Benutzer wäre es wohl am einfachsten. Und Aufgaben macht man eh nur einmal. Also man schickt jedes Mal die Informationen. Ja, einfach Befehl ausführen und kurz warten und dann kriegt man das Feedback und dann war es der Schritt auch schon.
Hi Simon, wir sind zurzeit dabei.
So currently we are trying to use a check-in state for a central notification point, and you have just shown us that through the API you can create users. What I would like to see and what I find very exciting is to have devices that are based on the user, because with the rule and notification you can give the user different notification devices, and this as an automation would be awesome. At home, or no, at work, I built this. To create these users automatically and to make sure they have certain devices linked to them, and then also link that to groups. We had an alarm point system before, and we want to get rid of it and do it with a rule-based notification in the event console. Yes, it's something that's interesting. It would be a feature request, I guess.